Today, we will be looking at rate of change, constant rate of change, and slope. The rate of change is a rate that describes how one quantity changes in relationship to another. In a linear relationship, the rate of change between any two quantities is the same. A linear relationship has a constant rate of change. A computer programmer charges customers per line of code written. Fill in the blanks with the amount of change between consecutive numbers. So in this line of codes, it says you can buy 50 lines, 100 lines, 150, and 200 lines. You can see that that is going up by 50. In the second line, the cost, Y, is going up by 1,000s, from 1,000 to 2,000 to 3,000 to 4,000. So as my X number changes by 50, my Y number changes by 1,000. It says label the diagram below with the terms change in lines, change in dollars, and constant rate of change. So change in lines is down here on the bottom. So notice the X number is on the bottom, and so we put change in lines here. We could also call that change in X, and I'm going to use this triangle. It's called a delta, and delta actually means change. So change in X, change in lines is 50 lines. The top here, the $1,000, that shows the change in dollars. And I'm going to put change in Y since that was our Y numbers. So change in Y over change in X. If I divide that, we can see that the unit rate is $20 per line of programming code. This is also called the constant rate of change. It's also called the constant rate of change. Page 66 says you can use a table to find the constant rate of change. It says the table shows the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. Like in the previous example 1 here, and please write this one down, you can see that as the number of cars, X, goes up here, it is going up by 5s. You can see here as the money goes up, we'll call that the Y number, that it's going up by 40. So we can do our change in Y over our change in X, which would be the change in the amount of money, 40, over the change in the number of cars, 5, and you can see that that's going to come out to $8 per car. This is called our unit rate, which we've learned about before, but it is also called our constant rate of change. Let's take a look at example 2. You can also use a graph to find a constant rate of change and analyze points. Let's take a look at example 2. You can also use a graph to find a constant rate of change and analyze points on the graph. The graph here represents the distance traveled while driving on a highway. Find the constant rate of change. So first of all, you will notice that this graph is showing a proportional situation. That is, it has a straight line through the origin. We know that we can then say that this situation is proportional. So I'm just screwing this one up. The first thing you're going to notice on this is that it is a straight line through the origin. So we know the situation is proportional. So there is going to be some kind of unit rate, but no constant. That unit rate is also the constant rate of change. How do we go about finding that from a graph is what we're going to talk about right now. And the first thing is you need to identify some points along the graph. They've marked the points here. That's not always going to be the case. When you find your points along the graph, you want to find it where there are crosshairs. What I mean is, I don't want to go to where this line crosses here. I don't want to go to where this line crosses here. That's not a crosshair. Instead, I want to go to where there is a definite crosshair, because then I have two numbers that I can work with. So you could see this point is at 1,60. The X number goes first, the Y number goes second. Then we go up to our next point where we have a crosshair, and you have 2,120. Then you go to the third point where there's a crosshair, and it's 3,180. We then want to take those points and we want to find the change in X, the change in Y over the change in X. So I want to go, what is the distance between 120 and 60? I want to do 120 minus 60. I want to do the same thing with the X's. What is 2 minus 1? And what I come up with is 60 over 1, or 60 miles per hour. This is our constant rate of change. And it is also our unit rate, 60 miles per hour. It is both the constant rate of change and the unit rate. And we could, because this is a proportional situation, write this in the form of an equation. We can say that Y is equal to 60 times X, where X is the amount of time in hours, and Y is equal to the total number of miles traveled. So if we travel for 0 hours, we go 0 miles. That's 0, 0. If we travel for 1 hour, we go 60 miles. That's 1, 60. If we travel for 2 hours, we go 120 miles. That is 2, 120. If you travel 3 hours, 3 times 60 is 180. That's 3, 180. So this is what the linear function or linear equation would look like for that graph. Example 4 from page 68. It says the table in the graph below show the hourly change to rent a bicycle at 2 different stores. Which store charges more per bicycle? What we need to do is we need to find the constant rate of change or slope for each one, because it's going to tell us which one has the higher unit rate. Over here, because we have just a table, we would do our change in Y over our change in X by simply looking at how they change. As this goes up by 1, this is going up by 12. So we can say change in y is 12, while change in x is 1. So the constant rate of change is 12, or $12 per hour. Take a look at the graph. Since none of our points are labeled on our graph, we kind of need to go and label them. You will notice they put a couple points on here. They put points that are easier to work with. They chose 1, 8, and they chose 2, 16. When you are finding slope or constant rate of change on a graph, you really only need 2 points as long as the line is straight. So again, we're going to do change in y over change in x, but we are going to use 16 minus 8 for our change in y, and we're going to use 2 minus 1 for our change in x. That gives us 8 over 1, or 8. And again, it is dollars per hour. You will notice that they did not label their x-axis correctly. They didn't put hour down here. So the question is, which store charges more per bicycle? Well, that would be Pedals, because Pedals is charging $12 per hour. That is their unit rate, while Supercycles charges only $8 per hour. If I wanted to write an equation for each one of these, this one would be y equals 12x, while this one over here, Supercycles, would be y equals 8x.